Welcome to Unit 3, Lesson 4. Today we want to talk about multiplying polynomials. When we multiply polynomials, we can use one of two methods, and it'll be your choice which method you want to pick to use. The first method is to multiply using the distributive property, while the second method is to multiply using an area model, or what some people refer to as the box method. The distributive property is nothing new. When we want to take a monomial and multiply it by a polynomial, we can distribute the monomial to each term of the polynomial. So here I have a monomial of 3a squared. I can distribute it to all four terms of my polynomial here, and then can use my rules for multiplying monomials to find the product. This would become 3a squared times 4a to the fourth. I would then distribute the 3a squared here, and we would have 3a squared times negative 3a to the fifth. Distributing over here, we end up with 3a squared times 2a squared. And then finally, distributing over here, we end up with 3a squared times 2. Using our rules for multiplying monomials, we can now multiply these things together. We multiply the coefficient. 3 times 4 is 12, and we keep the base, and the rule says that when we are multiplying, we add our exponents. Over here, 3 times negative 3 makes negative 9. Keep your base, add your exponents. Here we have 3 times 2 is 6, and a squared times a squared becomes a to the fourth. And finally, 3 times 2 makes a positive 6, a squared. At the end of our problem, we'll simplify by combining any like terms, which we do not have. And then finally, we will rewrite our problem in descending order, where the highest power of a is going to come first, so negative 9a to the seventh, followed by our next highest power, which is a positive 12a to the sixth, then a 6a to the fourth, and finally a 6a squared. We can work that same problem using what we call an area model or the box method. We will create a box that is the same size or has the same dimensions as the polynomials we want to multiply. This is a monomial, so we need a box that is 1 by. This is a trinomial, so we need to create a box that is 1 unit wide by 3 units long. We will put our monomial here on the left, 4a, and our trinomial here across the top, a squared, negative 2a, and positive 3. To create this box, to find the area, we would take the length of this, which is 4a, and multiply it by the width that is a squared. 4a times a squared makes 4a cubed. To create this box, we are going to take our length, which is 4a, and divide it by our width, which is negative 2a, giving us negative 8a squared. And finally, 4a times 3 gives us 12a. Our final answer here is 4a cubed minus 8a squared and a positive 12a. We can use these same two methods to multiply now a binomial times a binomial. So with a binomial times a binomial, we just need to distribute. The first thing I see in this parenthesis is a 3x. I want to distribute that to both terms that I see over here. So 3x times 2x, and then the 3x also needs to get distributed to the 8. The 3x wasn't the only thing I had in that parenthesis, though. I also had a minus 4. I now need to go back and distribute that negative 4 to both of the numbers in the second parenthesis. So negative 4 is going to get distributed to the 2x, and negative 4 is going to get distributed to the 8. You may have heard this last year called the FOIL method. First, I multiply the first thing in each parenthesis, so 3x got multiplied by 2x. Outer, I multiply the thing that's in the outside of this parenthesis with the thing that's on the outside of that parenthesis, so 3x gets multiplied by 8. Inner, what's on the inner side of this parenthesis is negative 4, and on the inner side of this parenthesis is 2x, so negative 4 multiplied 2x. And finally, last, I multiply the last thing in this parenthesis by the last thing in that parenthesis, negative 4 times 8. All right, applying our monomial rules to multiply these, we multiply our coefficients, we add our exponents. X to the first times x to the first makes x squared. Multiply my coefficients. 3 times 8 is 24, and I just keep my x. Over here, I multiply my coefficients. Negative 4 times 2 is negative 8, and I keep my x. And then finally, over here, negative 4 times 8 is a negative 32. Right? I should notice that there are some like terms in this problem to combine. There is no like terms with my 6a squared, so I'm going to leave it. My 24x and my negative 8x are like terms, and when I combine those, 24x take away 8x gives me 16x. And then finally, I finish off with my minus 32. Let me double check that this is in descending order. I have the highest power of a coming, sorry, that should be an x coming first, followed by 16x coming second, and then my constant term or no variable term coming last. We can work a similar problem, x plus 4 squared, also with binomial times binomial. Again, you may use the area or the distributive method. I'm going to use the distributive for this one. X plus 4 squared means that I have x plus 4 times x plus 4. Please write it out like this. And now we'll complete our problem. I'm going to take this first thing here and distribute it to both of those things in the second parentheses. So x is going to get distributed to x. X is also going to get distributed to 4. I am now going to go back and take the 4 and distribute it to both things in that parenthesis. So 4 is going to get distributed to the x, and 4 is going to get distributed to the 4. Cleaning this up, x times x gives me x to the second power. 4 times x gives me 4x. 4 times x gives me another 4x. And 4 times 4 gives me 16. Finally, I'll combine like terms. There is no like terms with my x squared. I should see that 4x and 4x can combine to make a total of 8x. And then I have my constant term of 16. This is in descending order. The key to this problem is just making sure that you rewrite x plus 4 squared as x plus 4 times x plus 4. We can work similar problems using the area model. In the area model, remember, we're going to create a box that is the same dimensions as the size of our polynomial. In this polynomial, I have 2 terms, and in this polynomial, I have 2 terms. So I'm going to create a box that is size 2 by 2. On one side of the box, I'm going to place the 2 terms for my first parenthesis, a 3x and a negative 7. On the other side of the box, I will place the 2 terms for my second parenthesis, an x and a positive 9. We multiply the length and the width to get the area of each box. 3x gets multiplied by x to make 3x to the second. 3x gets multiplied by 9 to make 27x. For this box, negative 7 is going to get multiplied by x to make negative 7x. And finally, negative 7 is going to get multiplied by 9 to make negative 63. This means that I have 3x squared, a positive 27x, a negative 7x, and a negative 63. When we combine our like terms, we end up with 3x squared, negative 27x, and positive 7x give us 20x, and a negative 63. Our problem is in descending order, so we are finished. Again, for the second one, I need to understand what it means to square something. It means that I'm going to take 2x plus 1 and have that as a factor 2 times. To create my box, I'm going to look at the size of my polynomial. This is a binomial that has 2 terms. This is also a binomial that has 2 terms. So to use the area model, I need to create a box that is 2 by 2. Along one side, I will put 2x plus 1, the factors here. And along the other side, I will put the 2x plus 1, which is from this factor. And again, we multiply the length and the width to fill in the box. Here, 2x would get multiplied by 2x to make 4x squared. For this box, 2x would multiply 1 to make 2x. This box, 1, is going to multiply 2x to make 2x. And finally, 1 will multiply 1 to make 1. This gives me 4x squared, a positive 2x, another positive 2x, and a 1. When we combine our like terms, we end up with 4x squared. 2x and 2x combine to be 4x plus 1. We are in descending order, so we are completely simplified. The last multiplication we can do is a polynomial times a polynomial. We will continue to use this idea of distributing. I have two things here, and both of them need to be distributed to all three terms over there. I'll start with my 3a. 3a is going to be distributed to a 4a squared. 3a is also going to be given to the negative 6a, and 3a will be given to the 8. I'll go back now and distribute that negative 9. Negative 9 is going to be given to the 4a squared. Negative 9 will be distributed to the negative 6a. And finally, negative 9 will be distributed to the 8. Right? Going through and multiplying, 3a times 4a squared makes 12, a to the third power. 3a times negative 6a gives us negative 18a squared. And 3a times 8 is 24a. With our second set of distributing, negative 9 times 4 is negative 36a squared. Negative 9 times negative 6a gives me a positive 54a, and then negative 9 times 8 is negative 72. Our last step is to combine our like terms. Combining our like terms, there are no other a cubed terms, so we'll leave this as 12a cubed. We can take our negative 18a squared and combine it with our negative 36a squared, and that will give us negative 54a squared. 24a is going to get combined with 54a to give us a total of 78a. And then finally we have our constant of negative 72. My powers are in descending order. A to the third goes down to a to the second, which goes down to a to the first, which goes down to no a's at all. Finally, we can complete a similar problem, which is a trinomial times a trinomial, also using the area model. There are 1, 2, 3 terms here and 1, 2, 3 terms here. So I need to create a box that is 3 by 3. Across the top of the box, or along the side of the box, I can list one of my trinomials. So I've got a 3x squared, I've got a 2x, and a 7. And across the top, I can list my other trinomial, negative 5x squared, 2x, and negative 8. And then I just multiply the length and the width of each box to fill the box in. 3x squared is going to get multiplied by negative 5x squared to make negative 15x to the fourth. 3x squared gets multiplied by 2x to make 6x cubed. And 3x squared gets multiplied by negative 8 to make negative 24x squared. Here we have 2x times negative 5x squared to make negative 10x cubed. 2x times 2x gives us 4x squared. And 2x times negative 8 gives us negative 16x. Last row, 7 times negative 5 is negative 35x squared. 7 times 2x makes 14x. And finally, 7 times 8 is negative 56. We often find that our like terms will be located along the diagonal. I didn't show you that up here, but negative 7x and 27x were like terms and along the diagonal. 2x and 2x were like terms and along the diagonal. I can see the same thing happens here. My x cubes are along that diagonal, my x squareds are along this diagonal, and my x terms are along this diagonal. Combining like terms, I end up with a negative 15x to the fourth, a negative 10x cubed and a positive 6x cubed get combined together to make negative 4x cubed. negative 35x squared, 4x squared, and negative 24x squared gives us negative 55x squared. Here, 14x and negative 16x give us negative 2x. And then finally, my constant is negative 56. Notice that my terms are in descending order: x to the fourth, x to the third, x to the second, x to the first, and then my constant. Again, you can choose which method you prefer, the distributive method or the area or box method.